Welcome everyone, my name is Jeff Smith, and this week I'm going to try to make this a shorter call than what we've been doing. We've been going almost 45 minutes an hour, and I think that's just too long, especially for those folks that come in after the fact and watch the recordings. So I'm going to try to do this in about 20 minutes, 30 minutes. If folks have questions, feel free to put those out there. You can put it out there audibly if you want to unmute your mic, or you can use the chat. So I have some slides. I'm going to do some live demo just to kind of set today's goal. It takes about 5 minutes to get SQL Developer downloaded and installed, and it takes about 5 minutes to be up and running with the debugger. So today I want to cover all of this, but just a general overview. Some of you may have never used an actual debugger in an IDE before. So I'll talk about what that means versus manually running your program and instrumenting it with code. And then we'll step through a debugger, and then I might show a couple of debugger tricks. And I'm demoing this with version 4.1 of SQL Developer. The debugger has been in the tool since day one. It hasn't really changed that much since it came out. I have seen some talk of doing some major enhancements to the debugger engine itself in the database in 12CR2, but that's so far out, it's not really something for you guys to worry about yet. A lot of PL SQL IDEs out there. Some are free, some cost money. Almost all of them have debuggers. And what those are graphical user interfaces that either work with the DBMS Debug PL SQL package or the JDWP debug package. So they're both making calls to the database to handle the debug session. They all work generally the same way. What I'm going to show you today in SQL Developer, you could, apply regardless of the tool you're using. I hope you're using our tools. You're here for this. There's a good chance you are. I'm already talking too much. So I'm using 4.1 that was released second week of May. Everything I'm showing you goes pretty far back. Only real wrinkle is I'm using database 12c to do this debug demo, and there is an additional prerequisite to start a debug session in 12c. Before I get into that, what do I mean by debug? I can't remember if I have bullets on here or not. Yeah, so for some people, they're going to run a program and see what happens. That's what also some people refer to as testing. So maybe you check the contents of a table you're writing out to, or check file system. Maybe you're making UTL file calls to create files, write to files. Or maybe you just have some logs that you'll step into. For others, and actually this is probably the majority of PL SQL developers that I run into, or if you're like me, PL SQL hackers, you just write a bunch of instrumentation code, which generally takes the form of DBMS output. So they'll write, DBMS output, here I am, X is equal to this, run the program, and go check the buffer afterwards to see what happened. And that really is debugging from that perspective. But what type of debugging I'm talking about is you have a modern programming interactive development interface or environment, and you've got these nice little buttons that you click that say step through, step over, step into, it has watches, breakpoints. And that's what I'm going to talk about. So I'm not saying the other two things are wrong, but when I'm using the word debug in the sense of PL SQL, and especially using an IDE versus SQL+, I'm talking about this third style. Like I said, there's nothing wrong with dbeam as output. Probably the biggest detriment is, well, you have to write extra code, which you might have to take out when you're done. But it's always after the fact, so you don't see it as it happens generally, and you're not able to interact with the environment as you're running your program. So how do we launch a debug session? So people are always asking me, what privs do I need? And this debug connect session privilege, I think, was introduced in 10G. So you want to make sure your DBA has granted you that. This is where it gets not tricky, but this is where it gets different from going from 11GR2 to 12CR1. And that is in database 12C. The database has introduced an additional layer of security, which by default prevents the database from calling out and making connections to other things. And how the debugger works is, instead of SQL Developer making a connection to the database and running the debug session, the database actually makes a call to SQL Developer, and SQL Developer runs the debug scenario. So for that to work, you have to make a call. And there's a couple of blog posts out there, and of course I can refer you to the docs. Let me see if I can find it here in my history. Oh, what was that called? ACL? Yeah. Well, I thought it was going to be in here. Oh, do I have a filter? Oh, I ran that in a different version of the tool. That's why it's not seeing the history. Duh. So I've also got this blog post up that you can refer to after the fact, and I've got a slide deck up on the intertubes as well. So I just talked about this not long ago. What you need to do in 12C basically is you make a package call to this ACL interface, and you say, hey, it's okay for me to execute or initiate a connection to this machine for this user. Come on. And I've got a link to a nice blog post from one of our developers that talks about it, and it's linked in here. Yep. The rub with this is you're going to have to ask your DBA to do this. So they're going to need to know your subnet or your specific machine address, and they're going to need to know the user that you're going to be debugging as, and you're going to need to know the port number. Now, the nice thing is that you can use wildcards, so you can open up access across an entire subnet. So if all of your developers are, in one building, they can do that, and you can open up an entire range of ports or just one specific port, and you can tell SQL Developer which port to listen for those debug connections on. Most of you probably aren't on 12C yet. So a good number of you are. So for the 12C bit, look into that. After that, it's easy. You just open your program in our procedure editor, which is not a worksheet with your code in a big long script file. It's actually loading up a PLS file or coming in to here and double clicking in the database tree, which will give you this style editor. And then from here, you just click the bug button. It's a picture of a bug. It's actually the debug button. Now, 99 times out of 100, you want to compile for debug, and hopefully you're debugging in a test or development instance and not in production. If you're in production, I mean, you can obviously debug there, but most of the time I would say developers shouldn't be in production. But more importantly, when you compile for debug, it adds overhead to the stored procedure. So the database is collecting extra information to allow the debugger to do cool things like honor breakpoints and use watches and step into other programs. And smart people at Oracle have told me that the overhead is noticeable. So if you compile for debug, make sure you take the debug information off before you add it into your production system or any environment where performance is important and you're not debugging. When you compile for debug, we will actually paint the tree with an extra decorator. So these two procedures are compiled with debug. None of these are. This program has an error. So you can see very quickly, if you log into production and you see these little green bloops, that might be an issue. So you'd want to compile without debug. Yeah, so click the big bug button. So what happens when I do that? So when you're debugging, you're actually executing. So if I were in a package, I would have multiple targets over here to select from. I'm debugging a stored procedure, just a simple function. So the target is just the function itself. And you need to supply the input parameters to do the debug. So I'm sending in a number. And I'm going to say, OK. So I can see here it's actually stepping into the machine that SQL Developer is running on, which in this case is my laptop, not the machine where the database is running, which is in my VirtualBox environment, which is just an image running inside a virtual machine on this laptop. And this port number here, 4000, is being specified in preferences. I've told SQL Developer when I do a debug session, I want it to talk on ports 4000 to 4000. So when you ask your DBA to set up the access control list for the JDWP for the debugger on the database, if they tell you, okay, but I'm only going to do it on port 11,555, just set your minimum and maximum port range to that number. There's another important setting here, and this gets people a lot. Start debugging option. The default is run until a breakpoint occurs. Now you'll notice when I told you what you need to do to start a debug session, I didn't tell you anything about setting a breakpoint. Well, I had a breakpoint set in here, and this little red arrow indicates that the debugger is sitting on line 30 and is waiting for me to do something. If I had not set this breakpoint and I didn't have any exceptions in my application, down here in the log, you would have just seen debugger accepted connection and debugger finished. And you've been like, hey, I wanted to debug. So you need to always set a breakpoint, or you need to come into the preferences and change this option from run until to step over. If you have it set to step over, it'll start at the first line of the program and then ask you to pick up from there. So let's actually do that. I can tell already I'm going to go longer than 20 minutes, but I'll try. Okay, so now I've started up here on line 1. This is an executable line of code, and I've got 2 debugging toolbars. I've got one up here at the top, and I've got another one down here in the debug panel itself. They both do the same thing, just use whichever one is more comfortable or available to you, and you can always pick this up and dock it somewhere else if you want. Maybe I want to do that. So step is going to take me to the next executable line. These lines right here are actual lines of code, but nothing's actually executing there. this is an executable line of code because I'm declaring a variable and I'm also setting a value for it. So I'm sitting on line 9, but if I put my mouse over X, this is just a hover watch, it's trying to tell me what X is equal to. It's telling me it's null because it hasn't actually executed yet. So I go to my next executable line by doing a step. If I come back over here to X, I can see now X has been initiated to this string. If I want to come look at my watches, I can add a watch to X so I can always see what X is equal to and make changes to it. So I can say watch. So now X, well, it should be showing me that value there. I just demoed this and let me do it then. There we go. Maybe found a bug. I can change the value. Maybe I want X to be equal to something completely different. Oh, I don't know. For Chet, if he's watching, you can set it to his favorite. So in the memory space in which this program is running, X is now equal to PBR. So being able to change things on the fly in a debug session is very nice. I don't have to hack up my program to artificially make things occur to introduce a scenario where someone's reporting a bug or something weird happening. You can set watches on application elements, variables, and set those values to anything you want just to see what's going to happen on the next line of code. I've mentioned stepping a couple of times. So we have step over and step into, and these things do the exact same thing most of the time. And step over basically says, go from this line to the next line. Step into says, if this were an application call, like if I were down here on this line and I click the step into, it actually will open up that program that's being executed and will debug that. But if the next line of code is not a procedure call, step into has the same behavior as step over. All right. Here is a breakpoint, and I've given it a pass count of 60. So what that means, I have a loop here that's going to be executed however many times. And maybe I want to jump forward, to the 50th iteration of that loop. So if I set a breakpoint, and to set a breakpoint, you just click in the gutter, and then I'll add it. Now it's important that you add the breakpoint on a line that's considered executable. If not, if it's a comment or just some simple thing that's not actually executable, the breakpoint is ignored. This one definitely is. I could hover over that and set either a condition. I could say, X equals to 12, and the breakpoint would be ignored unless X actually evaluates to 12 at that point in time. Or I can give it a pass count, or I can do a pass count and a condition, in which case they both have to evaluate to true. So this is saying, go through this loop, and on the 49th pass, stop. And that just keeps me from having to click step over 49 times 4 times to get to that iteration. So what I'm going to do is I'm going to say resume, which just says just go for as long as you can until something makes you stop. So it took a while. It executed a bunch of times, and it's now on this line of code. And I have this counter here, and if I look at my counter, I can see that it's set to 48. So it's run through that the number of times that I've expected it to. So again, this is a hover watch. So this is a simple value. This tab, however, is not. This is like a PL SQL table. Now I can use the hover watch on this too. It gets a little bit convoluted. So you could click 6 times to see what's into that. Or you could also come down here into this smart data or data panel. And for this PL SQL table, which is indexed by binary integer, which is why I'm seeing these integer values here, I can click into the record to see what's in that row for that PL SQL table, for that value of the array, basically. So quickly, just to recap what I did there, I set a conditional breakpoint, and then I clicked the resume button. And what the resume button does is it says, okay, just go back to execute mode and don't stop until you hit a breakpoint or an exception, or until you get to the end of the program. I can now step again if I want, however many times that's going to take, or I could set another breakpoint. So you can set breakpoints during the debug session. Hit resume again. Oh, you know what? Take that out. There we go. So now I'm sitting on this call, and this is where I want to introduce the concept of the call stack. Call stack basically shows me where I'm at and kind of where I came from. So remember when we started the debug session, we initiated the program with this anonymous block. This is the actual code that we kind of stepped into. Right here is where the function is called. So the debugger kind of stepped into here, got to this line, stepped into this. So I came from line 7 of this, and now I'm on line 35 of debug demo. And if I hit step into, now I'm on line 1 of this procedure. I came from line 35, which came from line 7. So when you're debugging other programs, the scope of your watches and data and all that good stuff is completely different, which is good, because if I had variables len or x in here, I don't want to see what those are equal to from my debug demo. I want to see what x and len are equal to in this procedure. So name, so if I set a watch of who here, man, it's always good to find bugs. Java's case sensitive, by the way, which is why I had to change that from uppercase who to lowercase. I added this watch, and it's still going to be here when I step out. So there are two ways to get back to where I came from. I can say step out of here, which isn't saying, hey, do something not nice to your girlfriend or wife. We're not stepping out on loved ones. We're stepping out on the current unit of PL SQL. So it's still going to execute the rest of the program. It's not like there's some special abort mode here that says stop doing whatever you did here and get back. Step out just says go to the end and come back. Or you can simply step until you get to the end, and then it automatically takes me back to what the next line of code would be. So here's a call on x. X equals upper x. Let's change x to that. And look, my call worked. This upper is a function call, but you can't step into that. I've also noticed stepping into programs doesn't work very well if the program that you're stepping into hasn't also been compiled for debug. So most of the time you're just compiling the program you're debugging for debug information. But if you're going to be stepping from that program into other ones, don't forget to go compile those programs for debug also. And at this point, or at any point, I can hit the stop button, or I can just step over until I get to the end. So now here I am back to my anonymous block that started the whole thing. And I'm just going to stop. So here's the log from the debug. We can see what it did, how it works. It says, go reach out, find me on this port. The debugger is running actually from SQL Developer itself. It's listening on port 4000. You can see where the breakpoints are encountered. You can see where the session died because I hit the stop button. We're saying, okay, disconnect the debug session. Nothing's more to read from the connection. And we're good. Now my database connection over here and this is still going in just fine. So I went 25 minutes. That was kind of a basic overview of the whole thing. So just to recap, before you actually hit the debug button, either change your preferences to step over or hit a breakpoint, or it might look like nothing's happened. It's actually ran, it just didn't have any reason to stop. Breakpoints allow you to stop execution or halt execution, pause it, I guess. And there's a couple different ways you can add them. The easiest way is just to click in the gutter, a single click in the gutter, or you can actually add them in the breakpoint panel itself. And you can have conditional breakpoints, which are most useful in the loop. So you can add a pass count. So in this case, that line of code would execute 500 times before it would break. So it's just a nice way to kind of fast forward through a bit of your code. Step over versus step into. So if I'm on a line of code that actually calls another program, step over will still execute funcfdate. I just won't see it via the debugger. Step into will open funcfdate and let me debug that function until I step out. The call stack is nice. When you open the call stack, oops. Two things. Out of the box, we don't show line numbers. That can get a little confusing, especially when you're doing debugger stuff. So turn your line numbers on here. And the other thing I recommend is when you're debugging and you're looking at your call stack, by default, for some reason, we're not showing line number here. So when you're like 7 or 8 levels down, right click here and say line. So now I can see exactly what line I'm on. If you're curious about what smart data versus data is, data shows me all of the variables in the program and their values, and smart data, I believe, shows you like the last 3 that have been accessed. So it's smart in the sense of just show me what's been touched the last 3 times, the last 3 variables that have had their values change. This is probably the only tricky thing about the debugger. So it's all fine and dandy to debug from the IDE itself, but setting up the scenario, to replicate that weird thing that's happening in your application, when you're doing it from SQL Developer, you're kind of artificially creating that environment. You can debug the entire stack of your application by using external debugging, which is also known as remote debugging. So if you had, if you're using our .NET Teams Visual Studio tools, and you're building a C# .NET application that was making database calls and executing stored procedures, you could start out in Visual Studio, step through your C# app, and when it gets to the procedure call, you can actually step into and debug that. And what happens when you do that, SQL Developer is sitting there listening for the debug, for that execution to happen. And when it happens, it takes over. You alt tab over into SQL Developer, and then you're able to step through the program in that same connection, in that same memory space as it was launched from your application. I'm not going to demo that really quick, but there's two ways or two methods of making that happen. The easiest way is to set an environment variable on your machine where your application is running. And the other thing you can do is manually make a database call to set up the external debugging. And my colleague, Barry McGillen, I think Colm both have really nice blog posts that demo that or tell you how to set that up. So I'm listening for debug requests on the tree, on the connection itself. You right-click, say remote debug. You can execute this code. I say it's the hard way because you've actually got to, execute this code in the right spot in your app sometimes. This is the easy way on your machine. You just set this environment variable, and as you can tell, it's a lot easier to do here. I think that's it. I said at the very beginning, make sure you do all this in a procedure editor. So you've either got a PRC file or a PLS file that has your store procedure in it, or you're opening the object directly from the database. Don't have a script that has 15 procedures in it and try to do any of this in the worksheet. That's not going to work. When you're in the worksheet, you don't have the compile button, you don't have the debug button, you don't have the execute buttons, nothing like that. All right, so I'm going to open up for questions. I'll wait a few minutes, and if I don't see any, I'll stop the recording, wait another couple seconds in case anyone was too nervous to ask questions for everyone else to hear later. Now I can't find my Zoom toolbar. There we go. No questions? You don't want to read my email. One last plug. We updated our new command line interface, SQL CL, yesterday, which is a SQL Developer take on SQL Plus. That's available on OTN, on our SQL Developer page. It's got cool things like a new version of Describe, smart formatting here where you can see the column spacings automatically taken care of. You can set things like SQL format to CSV and then run queries. And have those automatically print out in the format that you want. It's just a Java application. It's a 10 meg download. Doesn't require any sort of client or instant client. So it fires up fast. It supports everything SQL Plus does, and then we've added a bunch of stuff, new commands. So native SSH tunneling, SQL history. Anyways, I don't want to go too far off topic. But I had your attention, so I took it. All right, I'm going to turn the recording off.